edge detection by using the Verilog language. Okay, so edge detection basically used in many kind of application. See, basically our chip is receiving the one input, that one input when it is going to high and when it is going to low, that we are going to detect in this program. The very simple program. Yes, the module input. So one is basically the input is clock 100 megahertz clock signal and another one input signal. That input signal only we are going to detect by using the master clock, that is a 100 megahertz clock. The output is edge underscore detect. So the input as well as output which we are specifying here, this is the inputs and this is our output. And another one register also we have created. Okay, see, always at the postage of this clock. So every clock edge, this will the inside the statements will be executed. So this is a behavior level modeling. Okay, so every clock edge I am going to detect that. Every clock edge means every master clock edge I am detecting by using this if concept. If clock 100 megahertz equal to 1 tick B1 means then the below statement will execute. Here I am using that non-blocking statement, that is very important. If you are using the blocking statement, then definitely you are not able to find out the edge detect. Okay, so non-blocking statement which will be using here. So after the one clock edge only, this output will be, after the one clock only the output will be updated. So in this way, the XOR gate, that means old data with the previous present data, we are XORing it. Then what will happen, whenever the changes happen 0 to 1 or 1 to 0, the output will be 1. Okay, see, this is our output we are getting here. See here, so here going low and here it is going high. So in this case what will happen, whenever the clock edge comes, the output will be, the edge will be detected. Okay, so suppose if you want to more know about the Verilog model simulation software, you can click this link. If you are clicking, you can see that also in the another video. Okay, so this is basically the model sim output window. Okay, this is the RTL schematic. See, in our program you can see that register we are using, that how it is converted here. You can see here two registers and edge 1 register and edge detect final output, both we are making as a register. So in such a case the XOR gate has been implemented here. Okay, though, so the previous the flip-flop output will be the previous input. So this is the present input. So whenever the changes happens, the output will be going high. Okay, if you want to know that more xilinx RTL schematic and xilinx flow, you can see in this video, like our previous video, beginning of a project, how to do that, all those things. You can click this window, you can observe more things. This is the utilization summary, how much utilization it is happening. We are seeing that two flip-flop has been used and one XOR gate has been used. Those are implemented by using that lookup table. Only one lookup table is required, so it is mentioning. And two flip-flops we are using that IOs. So totally how many IOs are there? 3 IOs, that is a 2 input and 1 output. 2 input, one is 100 megahertz clock and another one input primary, what we want to detect, in which line we want to detect that input. Okay, and one buffer also has been used. Here how much percentage it has been used, see here it is a 0.01, that is a very 1% lookup table have been used. Totally the available lookup table is more than 20,800 lookup table is there, and flip-flop 41,600 flip-flops are there. IOS 106 IOS we can use it. The device which we are using, that is XC7A35T1 CPG 236 IOs are there. Out of 236 we can able to use it 106 IOs. So this device has been selected, so based on that result which we are getting. And the power dissipation, basically power dissipation, there are two kind of power dissipation. One is dynamic power dissipation and another one static power dissipation. See, the static power dissipation reason is mainly the leakage current. Okay, but the dynamic power dissipation is mainly because of the how much a sequential circuit we are using, what is the clock frequency we are using and everything. So in our program, in our small program, we are the power dissipation is 517 milliwatts. At junction temperature is 27.6 degrees Celsius and thermal margin 57.4 degree, and static power dissipation is very less, which is 71 milliwatt.